in an observational study, this is where you simply observe, and you might take measurements, or you might hand out a survey. That's another way of taking a measurement for individuals. But in an observational study, we don't do anything to affect the results of the survey. We don't do anything to affect the measurements that we take during an observational study. In contrast to this, a designed experiment is one where we are going to still take measurements, but we're also going to apply some kind of treatment. We're going to intentionally change what the measurements will be at the end. That's what the distinction is between a study and an experiment. So, if the University of Texas was going to poll all the residents of Austin, Texas, and ask them which presidential candidate they prefer, this happens every election cycle. They try to come up with polls that are going to predict the election results. Would you say this is an observational study or a designed experiment? Yeah, this is just a study. Ideally, the people who are asking the questions are not doing anything to affect the results that they get. They're not trying to affect the opinions of the people who are responding. They're just trying to ask the question. Okay. If you are trying to research supplements and drugs, you're a pharmacy researcher, if you want to know whether or not a particular supplement, like, I don't know how to pronounce this, is effective for increasing the lifespan of mice. It's always nice to start off testing out drugs in animals, because that way you don't have to actually put people through it if there's any kind of negative side effects. And so this is the question you might answer. Is this going to require a study, or is this going to require an experiment? An experiment. Because the mice aren't going to get into the drugs by themselves. You have to apply a treatment to them, right? You have to take some of them and you have to give them this supplement. You have to affect what the measured result is at the end. And of course, the thing that we're measuring is lifespan. So this is an example of an experiment. Now, would you be surprised to learn that smoking decreases your odds of dying within the next decade? This was actually published in a journal called American Statistician, and this is real data that people gathered from surveys, basically. These statisticians went out and found people that were both smokers and non-smokers. And so the top row is smokers, the second row is non-smokers. And they asked them, at the beginning of a 10-year period, like in 1985, are you a smoker? Are you a non-smoker? Are you alive? Everybody said, yes, we're alive. At the end of the 10-year period in 1995, they went to follow up with these people. They went to follow up and just see, are they still alive? Or, do they get in contact with their family members and find out that they had died? And so, among those that were smoking, you can see how many are alive and how many are dead at the end of the 10 years and how many are alive and dead from the non-smoking group at the end of 10 years. And you can calculate empirically what their odds of death were during those 10 years. It's just the ratio. It's just saying 139 divided by 582 is 0.314. And you'll notice that for the smokers, the odds of death were lower than the non-smokers. Okay? That's kind of not what we would expect. We would expect that smoking is bad for you and it should increase your odds of dying within 10 years. Does anybody want to hazard a guess at what was going on when they performed this survey? These aren't made up numbers. This is stuff that was really actually surveyed and results they actually did discover and find. But what is happening here? Is smoking really good for you? No, probably not. Okay. The lesson to be learned here is when they were putting together their survey, their sample of smokers happened to be younger than their sample of non-smokers. And so when I split this up by age group now, and I say, let me only look at the cohort that was between 18 and 34, it turns out that, what do you call it? Not smoking gave you a better odds ratio, or a better odds of not dying within 10 years. And again, if I break it up into just the cohort that was between 35 and 54, non-smokers were twice as likely to survive. Group from 55 to 65, non-smokers were 1.6 times as likely to survive, and then 65 plus, I guess it didn't really matter that much again. But this again is the same exact data. It's just only now I'm being a little bit more careful with the way I analyze the data by splitting them up into age group first. Again, the reason why non-smoking seemed like it was so deadly is because look at all these super old non-smokers we have. And we don't have very many very old smokers. And that's really the difference, is that old people are more likely to die in any 10-year period, whether they're smoking or not. This is what we would call a confounding variable. If the question you're trying to ask is like, how does smoking affect your probability of death in the next 10 years? Age is a confounding variable. Whether or not you die in the next 10 years is a function of whether you're a smoker, but it's also a function of how old you are. And here's the typed out version. A confounding variable is a separate factor that influences the result of a study or experiment. If the researchers don't acknowledge what the confounding variables might be and separate that from the effect we're trying to measure, then it's going to invalidate your results. Whatever you're trying to claim is not going to be very accurate. You can do this either before the experiment starts, or before the survey starts, I should say, by choosing your sample really carefully. Like with the smoking example, you could fix that problem before the survey begins by making sure you have equal numbers of people falling in different age ranges when you start your survey. On the back end, sometimes you can fix this with just good math practices, right? Like if you've already conducted your survey and you already had bad sampling technique, sometimes on the back end you can still fix this using the right math techniques, like I showed you with the table, having split them up post-survey and calculating the odds ratios separately. That's a good technique for dealing with bad data. You should also know that if any of you in class are planning on becoming like a sociologist, psychologist, you want to do some of like the soft skills sciences, if you want to get into demographics or, even medicine or something like this, there are lots of people that have like a PhD in statistics that just work at universities, and you can reach out to them and ask for help. Like not here, not at MNU, but if you were going to like KU or like a big state school, there's lots of people there that have a PhD in statistics, and they know how to do this kind of stuff, both the front end and the back end, survey design and analysis. So don't try to do it on your own, especially if you're not very comfortable with math or statistics, right? Just reach out and get some help from somebody. Let's talk about another example. I'm going to follow this link and see where it goes. Well, I need to put away this pen. There we go. Drinking coffee might lengthen life. So that's the claim they're trying to make. Since this is Harvard Health website, I assume that they're making this claim based on some kind of evidence. They wouldn't just say this, because they felt like it. They most likely surveyed people, saw what their coffee consumption was, saw how long they lived, compared it against people who didn't drink coffee, calculated some averages, did some inference. They probably did some statistics to make that claim. But let's think for a moment. Could there be any confounding variables? Is there anything else that would also lengthen your life that might also coincidentally happen to people that drink coffee more than people who don't drink coffee? Does the question I'm asking make any sense? I'll give you an example for the coffee. Are you more likely to drink coffee if you work in an office that has a coffee machine down the hall? Or are you more likely to drink coffee if you are like a night shift worker out in the oil field, 10 miles away from civilization? The office workers, right? And so imagine this. If you are working a job where you're exposed to a lot of occupational hazards, like, for example, out in the oil field, if you're doing a lot of manual labor next to heavy equipment, then you're likely not going to be drinking coffee very much. And that also might shorten your lifespan. Like, there's already research that shows like working night shifts, shortens your lifespan versus people who keep a normal circadian rhythm. And if you're an office worker, you have a coffee machine down the hall, not only does that make you more likely to drink coffee, but it also probably extends your lifespan, because if you've got a regular sleep schedule, a regular work schedule, you're not putting yourself in harm's way, you're not exposing yourself to toxic chemicals, right? Those are all things that would generally increase your life expectancy. Another thing somebody pointed out to me at my last job when I was talking about this with other statistician people is they said that people who have higher income typically drink coffee more, right? Like if you have a really high paying job, you don't mind spending money at the Starbucks every morning. So you drop in and you get your $7 cup of coffee every morning before work. But if you don't make very much money, then you don't spend a lot of money on coffee. It's less convenient for you. Likewise, what about healthcare? If you have a really high paying job, you probably don't mind getting a bunch of preventative healthcare. But if you don't have a lot of money left over every month, then maybe you don't want to go to the doctor and maybe you leave some conditions untreated. So these are all confounding variables. These are things that affect lifespan, just like coffee might affect lifespan, but they are so correlated with coffee consumption that it would be really difficult to pick it apart and really determine what factor is contributing to the lifespan. Is it the coffee? Or is it something else that just happens to be coincidentally correlated with coffee? Does that make sense? So I was reading this article. It says, if your morning never starts with a cup of coffee, you might be intrigued to learn that drinking, whatever, blah, blah, blah. What am I actually interested in for? This sentence right here. I know it's really small. I'll read it. They accounted for such factors as lifestyle, diet, sex, age, and ethnicity. Now, I wish they would go into a little bit more detail on how they accounted for those factors, but basically what they're saying is, hey, we recognize that there might be confounding variables, and these are some confounding variables: lifestyle, diet, sex, age, and ethnicity. And so they did something. I wish they said what they did to account for that. But they either accounted for that on the front end by trying to recruit a diverse sample, or they did something on the back end, which you can learn about in other statistics classes, like multivariable regression, to try to mathematically remove the effect of compounding variables. But that's something we have to worry about when we design studies. Another vocabulary word is the word retrospectively. An observational study can be performed retrospectively, which means that a researcher can access and analyze historical records for correlations. My roommate in college was a guy named Jimmy, and he wanted to be a doctor. One of the jobs he got like a little part-time job during college, and his job was to look at old records from hospitals, right? So he's like looking at records between like 1900 and 2000, and combing through the records looking for mentions of particular symptoms, and then he would try to categorize those symptoms, because over the course of that century, doctors were naming diseases. And so what they wanted to do is they wanted to look back historically and see, did some patients present with these diseases, but we just didn't have a name for it yet? And maybe if we can look at those symptoms and we can diagnose them in the past and then categorize them, and then we'll know how prevalent these diseases were at the beginning of the 20th century, not just today. So that's a retrospective. Nobody was gathering data. The data was already there in the records, but it did take an underpaid undergraduate researcher to go back and look at the data and analyze it. That's called a retrospective study. And it's very cost effective because you don't have to spend any money gathering the data. When studying a population, if you select the sample in a way that's convenient, we call this convenience sampling. And most of the time this is a bad idea. If it's really, really easy, something's wrong. You should make it more difficult on yourself. The more rigorous way to do things is you could index the entire population. So when I use the word index right now, I'm using it as a verb. I'm saying go out and index the population. That means we're going to assign a number, 1, 2, 3, 4, 5, to everybody in the population. If I want to index this classroom, I can just go 1, 2, 3, 4, 5, 6, 7, 8. And now Alexis knows that her number is 6. And I can do that for the whole classroom, assign everybody a number. When I have my list of every single individual in the whole population and their number, that list is called a frame. In statistics, we call that a frame. And as long as I have a frame, I can do simple random sampling. And simple random sampling means I use a random number generator to select an individual from the frame. So I'll try to show you what that looks like. If my frame looks like this, and this is my numbered list, so this is my frame, all I have to do is use a random number generator. And in Excel, a random number generator looks like this. So when I hit the enter button, it's going to randomly give me a number, and that then selects somebody from my population to become part of my sample. And so you do this with your population. You run the random number generator as much as you want to gather a sample as large as you want your sample to be, and that's a randomly sampled sample. That's what we call a simple random sampling. And this is usually way, 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 way better. People like this a lot more. I'm going to try to come up with an example to show you. It says, suppose you work for the grocery store. Your boss wants to ask customers, are you satisfied or are you not satisfied with your experience shopping at this grocery store? And as an employee, she gives you a quota. She says, you better go to 50 customers this week and have them complete this survey. Now the store opens at 7 a.m. and you want to get this over with so you can go back to whatever you're doing on your phone, watching Subway Surfer videos or whatever you guys do. So what you do is you get there at 7 a.m. and the first 50 customers that go through the store, you give them the survey. And then, bam, by 8 a.m., you're done. You turn in your results, you're back to watching Subway Surfers. Is this simple random sampling or convenience sampling?
Sample.
This is what we would call convenience sampling. You chose the participants in a way that was very convenient to you. I said before that convenience sampling is normally a bad thing. Can you think of a reason that might be a bad idea? Conduct the survey that way?
Maybe 50 cars on time.
Maybe what?
Maybe not. You don't get all the cars that come by.
Yeah. We were never planning on surveying every customer for the entire grocery store, right? We were only ever going to get 50 customers. That was going to be a representative sample. So we don't have to worry about surveying every customer. But the problem is, if all of my customers that I survey are showing up to the grocery store between 7 and 8 a.m. on a Monday, that might not actually be representative of the customer experience in general, right? Maybe 7 a.m. on a Monday is whenever the other employees are stocking the shelves. Maybe after Sunday night, all the shelves are empty because people go and buy their groceries for the week on Sunday evening. And then on Monday morning, it might be really hard to find things they need. Maybe you're a customer and you go to the bananas and there's no bananas left, and you go to the milk and there's no milk left. And when you take the survey, you say, this was a really crappy experience, you know? But once the shelves are stocked for the week, later on throughout the week, maybe people have a better experience. And so you've biased the results of the survey by only selecting customers that show up at a particular time of week. And that's why this convenient sampling idea is normally a bad thing, is you're normally not getting a representative sample. What would it look like to do simple random sampling? Simple random sampling would be very difficult in this kind of situation because you would need to construct a frame first before you do simple random sampling. And so a frame might look like trying to get the names and phone numbers of every customer during the course of a week and then making a numbered list. That would be your frame. And then you'd use a random number generator to select customers from that list, and you'd have to call them and try to get them to answer the phone when it's not a number that they recognize. It would be very difficult to do a simple random sample. However, if you managed to put in the effort to do a simple random sample, then you would get a more accurate picture of what's going on because your customers were randomly selected from different times throughout the week. Suppose MNU wants to get student feedback about campus priorities. So they want to know, should we be spending more money on classrooms? Should we be spending more money on student activities? Or should we spend more money on the athletic teams? What would it look like to conduct a convenient sample? What's the most convenient way that they could sample students for this question? Mm-hmm.
Ask the first 50 kids that go to the path, like what we should be doing.
Yeah. They could just send an administrator to the cafeteria and ask the first 50 kids in the door in the morning, what do you think about this question? Is that a good idea or a bad idea? Why is that a bad idea?
Some of them could play sports and then some of them cannot, but it's not like an exact number. So it could
Yeah.
be like a bunch of sports teams and then they can have very little actual people who live on campus and stuff like that.
Yeah, Diego read my thoughts exactly. It's not guaranteed to be representative of the whole campus, because what if, hypothetically, the soccer team practices from 6 to 7 a.m. and then they're done at 7 a.m. and they all walk over together to the caf. And the first 50 students through the door are all soccer players. Whenever they answer this question, they think, well, I'm actually really a big fan of soccer, so maybe we should spend more money on the soccer team, you know? It might not be a representative sample of the student population. What would it look like to conduct a simple random sample? It's actually a lot easier in this case, right? Yeah, because MNU already has a list of all of their students, so they could number their students really easily, and then they could send you an email. Like Riley suggested, that would be super easy. And if you didn't follow up on emails, they could make me do it, right? Like, if Blaine is not answering his survey on the email, they could tell my boss to tell me to tell Blaine to answer this freaking question, man. So it's easy to follow up and force answers. It's hard to force someone to pick up a telephone or respond to an email, but in this situation, it would actually be pretty easy to do a simple random sample. Okay, there's another thing called systemic sampling. I'm not going to try to grill you too hard on this. You don't have to memorize this, but I just want to give you an idea of what systemic sampling could look like, because it's kind of a compromise between the two. If you want to conduct a systemic sample, guess your population size. It doesn't have to be an exact number, but you just take a guess. If you are working at the grocery store, for example, I guess you can see the example right here. You don't have to know the exact number of customers that are about to come through the grocery store this week, but you have to take a guess. Maybe last week's sales is a good approximation of what this week's sales will be. So you could use that number, which is not exact, but it's okay. We take a guess. Step number 2, you're going to figure out your desired sample size. So you just come up with a number that could be arbitrary. Maybe you say 50 customers. We're going to calculate the population size divided by the sample size and then round down. Choose a random number between 1 and whatever k happens to be. And then starting with that random number, so you wait until you get to number 6 or whatever. Start with that individual, and then after that, choose every kth individual after that. So let's talk about what it would look like to do this grocery store example. What if I expect 3,000 customers? That's probably low. What if I expect 4,000 customers at the grocery store this week? Oops. My brain is stuck on the number 3. Let's say that's my population size. My sample size is going to be 50, right? So my k is going to be 4,000 divided by 50, and that would be 80. Now I'm going to choose a random number, somewhere between 1 and 80. Like the number 37. And so starting with the 37th customer, I'm going to sample or ask the customer to fill out the survey every 80th customer. And so I look at the numbers that print out on the receipts whenever a customer goes through the line, and if they happen to be customer number 37, or customer number 117, or customer 197, and so on, you hit those magic numbers every 80th customer. That's when you stop the customer and say, hey, please, please, please do this survey. My boss is going to whip me if I don't. And this is, like I said, it's a compromise. It's not a perfect, simple random sample, but this is way better than grabbing all of the customers between 7 and 8 a.m. It's going to space them out throughout the week. And that's probably a better idea. That's called systemic sampling. All right, 2 more sampling techniques. We would like to reduce the required sample size. We're going to talk at the very end of the semester about how to determine what your sample size needs to be. Because the sample size that you need depends on what kind of question you're asking, and it depends on what degree of confidence you want. Do you want to be 90% confident, 95% confident, 99% confident? That kind of percentage confidence that you're aiming for is going to affect your required sample size. But we can still talk about this in general. It could help reduce the required sample size if we use a strategy called stratified sampling. The way it works, step number 1, partition your population into multiple non-overlapping strata. in that strata, we expect individuals to give a similar response. So, does anybody in this room play more than one sport? Great. So everybody either plays one sport or zero sports, right? So an example of creating a stratified sample in this room is I could say, I'm going to make one stratum, and by the way, strata is the plural form. I'm going to write this down. The singular form is stratum. The plural form is strata. So many stratums are strata. Sorry. But the way I would stratify this classroom is I would say there's going to be one stratum for the soccer players. There's going to be one stratum for the baseball players. There's going to be one stratum for the people who run track. There's going to be one stratum for the people who don't play sports, and so on, right? Those are non-overlapping groups because nobody plays more than one sport, and that's the way to do it. And depending on the question I ask you, I might ask people to give similar responses according to which stratum they belong to. And then when you do this, you want the subsample, the size of the sample you pick from a particular stratum, to be proportional to the size of the stratum. Another idea, let me just come up with an example on the fly. If I was in Chicago, the Chicago metro area, there's a lot of Polish people in Chicago, a lot of immigrants from Poland. But it's not like the majority of the population. It might be like 10 or 15% of the population. I don't remember. So if I was going to conduct some kind of survey that mattered what ethnicity you belonged to, I would want to make sure that since Poles are 10% of the population, Poles need to make up 10% of my sample. That's what I mean by step number 3. This example says, suppose you're a state representative, you must vote on a bill that would provide better funding for schools, but it would raise the sales tax from 8.25% to 9%. You want to seek the input of your constituents. That's a little bit of a convenient fiction. I know that representatives don't actually care about their constituents, but you know, for the sake of this class. Let's say you want to conduct a survey. What would you do to stratify your constituents, sort them into stratum, if the question is, do we need to increase taxes to better fund our public schools?
You go based off of like wage.
Yeah, because how much you earn might affect your tolerance for taxes. That's a really good idea. Anybody else have an idea? Who cares how well funded the schools are? Parents, yeah. If I were trying to come up with like the perfect stratified sampling strategy, it would be a great idea to sort people by income, because in theory, people with a lower income are less tolerant about raising taxes because they have less expendable income. Another way is you could stratify by whether or not you are a single person, a married person, a parent, a former parent, right? I say former parent. What I meant is like, do you have kids right now that are in K through 12 education, or maybe you did in the past? Because I would expect that parents who have kids in K through 12 education would say yes. And if you have a situation where you don't have kids in K through 12 education, and maybe you never want to have kids, you would probably say, well, you might not necessarily say no, but you would be more likely to say no for sure. And so you can actually do both. You don't just have to choose between the parent question and the income level question. You could stratify like this: high income, low income, on this axis. And then over here, parent of K through 12 or not. Right, and now I've got 4 strata, and I can sort all of my constituents into one of those 4 groups. And I expect that those 4 groups are more likely to answer in a similar way than complete strangers would. So that is stratified sampling. The benefit is that mathematically you are allowed to reduce your sample size and get a higher percentage confidence. The downside is that you kind of have to know about your constituents, and you have to be able to say, you know, that Drew Maka is a parent and what my salary might be in order to sort me into stratum. And maybe you don't always know that about your population. So that's the downside. Okay, and this is our last sampling technique that we're going to talk about. It's called cluster sampling. It's going to sound really similar, but it's different. Step number 1, we're going to partition our population into multiple non-overlapping clusters, not strata. The difference is that for clusters, we want the distribution of individuals in the cluster to match the overall distribution of individuals in the whole population. And this is surprisingly difficult to do well. What we wanted for strata is we wanted each stratum to be unique, like its own special stratum where we could probably predict how they were going to respond. We want the clusters to be the opposite. We want the clusters to be like the whole population, if that makes sense. We want them to be a mixture of views, a mixture of perspectives, a mixture of possible responses in the same proportions as the whole population. Because with stratified sampling, we were going to choose a sample from every single stratum and make sure that they were proportionally represented. But with cluster samples, we're not going to include most of them. We're going to randomly select which clusters to include. And if we forget about entire clusters and only choose some clusters, then the ones that we choose, we want them to look like the whole population. We still want it to represent the whole population. Within each cluster, we're going to use a simple random sample or a systemic sample, and then we are going to, of course, choose our sample sizes proportional to the cluster size, just like we did before. Here's an example. Let's say you're a U.S. Senator, kind of similar question. You want to raise taxes to increase funding for the military. You might survey your constituents, maybe, in an ideal world. They might look for feedback from constituents before making decisions. Cluster sampling means this. Cluster sampling means I don't want to have to travel to every single city and town in Kansas to talk to constituents. It would be a lot of time and money and effort to have to travel between cities to get in my car and drive all over the place. What I could do instead is I could pretend that every city and town is a little microcosm of the state of Kansas. Let's pretend that every city has the same distribution of opinions as the whole state. Then I can say every city and town is a cluster. I'll randomly select a few clusters and only travel to those. So instead of traveling to 100 cities, now I only have to travel to 5 cities. And it reduces my workload by a factor of 20. At least it reduces my driving by a factor of 20. This only works well if each cluster has the same distribution of opinions as the state as a whole. That's not always true. In fact, we expect like rural towns to lean conservative and big cities to lean liberal. And so it's not always the case that the clusters represent the population. If this works well, you want your clusters to be a representative of your whole population. So here's a little summary. Simple random sampling is really effective, especially if your sample size is large enough. The downside to simple random sampling is that it requires a frame. That means you have to know who all of the individuals are and assign them a number. And it could be costly. It could require a lot of time, money, and effort to produce that frame. Convenient sampling invalidates your data because it could introduce confounding variables. Systemic sampling does not require a frame, and so in a lot of ways that makes it better than simple random sampling if you can come up with a good method of doing systemic. Stratified sampling, the reason we might want to do that is if we want to reduce our required sample size. The downside is you have to know something extra about the population. For example, you might need to know whether or not each individual is a parent or not and what their income level is, as an example. Cluster sampling, like I gave in that example, it might reduce the effort and cost of having to travel between cities. But the downside is if each cluster isn't a good representation of the population as a whole, then that actually reduces the data quality. A lot of people get confused about clusters and strata. Like, what's the difference between cluster sampling and stratified sampling? Number one missed question on the test that comes up here. The three main differences is intent. With cluster sampling, our intent is to reduce the amount of time, effort, and money it takes. With stratified sampling, our intent is that we're going to reduce our required sample size. Coverage. What I mean by coverage is I'm going to have to sample from every single stratum. I need every stratum to be represented in my sample, proportionally represented. With clusters, I don't need to sample from all the clusters. In fact, that would defeat the purpose. With clustered sampling, I'm only taking a random selection of the clusters. I'm only going to go to a few clusters. And then the last thing is distribution. I want each stratum to be unique with their own unique views and kind of uniform in their views inside a stratum, but for clusters, I want there to be a distribution of views that matches the overall population. I'm going to go ahead and write some of these things out on my notes, like we sample from every stratum when you do stratified sampling. But for cluster sampling, we only sample from a few clusters. We want each strata to be unique and more homogeneous in perspective, kind of like whenever we were talking about funding K through 12 schools with tax dollars.
Is that for distribution? The third red one?
Sorry, what was your question?
Is that for distribution, the third red one? I just kind of forgot.
In orange, I'm trying to use orange to represent strata, and then blue is going to represent clusters. But right now, I'm given an example of what it means to be homogeneous in perspective. I expect high-income parents to want to fund public schools. I don't want a stratum to be representative of the population. I want each stratum to represent a specific viewpoint, like that. And like I said, if you're a non-parent and you have relatively low income, you might be more likely to want lower taxes. So that's an example of stratified. For clusters, we want each cluster to have a distribution of opinion that matches the distribution of the overall population. So, like I said, I know that cluster sampling and stratified sampling sound similar in a lot of ways because you're partitioning the population, but they're very different. Question?
What's the difference between them and the intent one?
Oh, let me scroll up to answer that question. The intent with stratified sampling is to reduce your sample size, the number of individuals you have to ask. The intent with cluster sampling is to introduce a little bit of convenience. Like, for example, traveling between cities is inconvenient. Cluster sampling is not going to reduce your required sample size, but it could make it so that you don't have to travel between as many cities.
Okay, thanks.
And this last two are for distribution.
Can you read my handwriting? Is it legible? Okay. Okay. So that's all the types of sampling we're going to talk about. We're almost done talking about sampling, but one more vocabulary word I want to hit you with is multi-stage sampling. Because you might have a scheme for sampling your population that involves clusters inside of strata or strata inside of clusters. I'm going to just give you one example that looks crazy complicated, but we'll talk about why it might be a good idea. So exercise 6 on your homework says, come up with a scenario in which a researcher wants to perform a survey and devise a multi-stage sampling method. This is what you might come up with. You might say, I want to know what proportion of Americans are in favor of legalizing marijuana, but I don't have a big budget to conduct this survey. So I'm not trying to do a simple random sample of the entire American population because I can't get their names and I can't assign them numbers and I can't travel to meet all of them. So that's beyond my budget. How do I save money while still getting a good representative sample? I could start by partitioning the United States into regional strata. So I'm going to take a sample from each region because regionally people might have different opinions about marijuana. And so I would stratify into the Southwest, the Southeast, the Midwest, the East Coast, the West Coast. Step number 2. Inside each regional stratum, I'm going to partition the cities and towns into strata based on metro area population. Because like I said before, rural cities and towns are more likely to lean conservative on cultural issues, and big cities are more likely to lean liberal on cultural issues. And so this would be another idea for stratifying. This time I have strata inside of strata, right? Within each region population stratum, I'm going to consider each city or town to be a cluster, hoping that if it's a town of about the same population in the same region, that maybe they would have the same distribution of opinion. So those would be valid clusters. And then, like cluster sampling suggests, I'm going to randomly select a few clusters to visit within each region population stratum. Step number 5. When I get to a city, I'm going to partition the neighborhoods into home value strata. Because in almost every matter of public opinion, you'll find that like upper class, middle class, lower class have different opinion distributions. And so it's always a good idea to partition according to home value or household income or something like that. In this case, home value is easy to look up for neighborhoods. Most neighborhoods are built with relatively the same home value. So I partition the neighborhoods into strata. Within each home value stratum, I'm going to consider each neighborhood to be a cluster, so that way I don't have to visit every neighborhood. I only select a few neighborhoods at random from each strata. Then, when I get to the neighborhood level, maybe I can find out the names of all the residents living in the neighborhood, especially if the HOA has a registry. That would be super easy. And then I could stratify them into age, because older people lean conservative and younger people lean liberal. So age strata is a nice way to do it. And then within each age stratum, I can do a simple random sample to select which door I'm going to go knock on. And that would minimize the number of doors I have to go up to and knock on the door and ask for the owner and talk to them about this opinion issue, right? The idea with sampling methods is always about minimizing the number of people you have to talk to, minimizing the number of cities you have to travel to, minimizing the amount of work and money you have to spend in order to get a good representative sample. So I know that sounds like a crazy, complicated amount of work, but this is stuff people really think about. Any large national polling agency is either thinking about this and getting a good sample, or they're not thinking about it and they're getting a garbage sample and it's making bad policy predictions, right? Bad decisions and bad representation. Okay, so moving on from sampling, we're going to talk about bias. When an ineffective method of sampling fails to reach a representative sample, and the result is a misleading data set, we say that that data set is biased, and we call this sampling bias, because the sampling is where we failed. What if Google were to conduct a survey to collect ratings of Apple Maps, and they're going to send out the survey to people who are using the Android OS on their smartphones? This is a personal story of my own. I used to use iPhones, but iPhone would always default to Apple Maps for navigation. And where I lived, Apple Maps had this super annoying habit of getting you within about a mile of your destination and then telling you to get out and walk. I kid you not, like, my apartment complex had a parking lot where I could park my car directly in front of my building, but it would lead me to like a mile west of my apartment, and then it would say, park your car, get out and walk. I'm not joking. Of course, this was 10 years ago, was the last time I used an iPhone. But if Google were to send me a survey, an Android OS user, I would say, yeah, I've got a negative opinion of Apple Maps. But that's biased, right? The people who like Apple Maps are not going to be using Android OS. So that's an ineffective sampling technique. That's sampling bias. Do you understand why? Okay. Okay. There's another method of introducing bias. We call it non-response. There might be a case when your sampling method is reaching out to the right representative sample. Like you've done a good job of selecting your sample. But another failure method is, what if the people you're reaching out to don't respond? This is a bad thing, especially if the people who are choosing not to respond would have responded differently than the people who are choosing to respond. Okay? So the president of MNU, he has everybody's email address, right? So he can email all of us. There's no deficiency in his sampling technique if he wants to reach out to every single one of us. But if he sends us a survey, especially if he, sends out a weekly email update and he includes the survey at the bottom of the update, and his survey says, are these weekly email updates helpful to you? He's reaching all of us. This is not sampling bias. But the people who choose not to respond to this question, this survey, are probably people who don't think these emails are very helpful, right? Like I don't read weekly update emails. Whenever they send those to me, I delete before I even open the email. So I would be a non-responder. But if there's people out there who love that kind of weekly update thing and they read every word, well, they're more likely to both respond to this and they're more likely to find that the email is helpful. And so this is a perfect example of non-response bias, because you have a difference in opinion, but you're not seeing the full picture when you get your results. Exercise number 8 says, list at least 2 ways we can reduce non-response bias. Can you think of 2 ways? I might have to help you with some of these because we've only got 10 minutes left. One way is follow-up. If I wait a week and no one's responded to well, let's say I wait a week and 90% of people have responded to my survey. I can send those remaining 10% a survey again. Walmart does this to me. I shop at Walmart one time and Walmart sends me a survey every week for the rest of my life in my email asking me to rate my experience, right? That's called follow-up, and that's could potentially reduce non-response bias. Especially if you say, okay, they didn't respond to my email, I'm going to try to call them. Okay, they didn't respond to my phone call, I'm going to go to their front door and knock on the door. You know, if you try to get more aggressive about your follow-up, that's could help reduce non-response bias. Another way is money. You could pay people to take surveys. Google pays people to take opinion surveys. There's an app called Google Opinion Rewards. And so I signed up for Google Opinion Rewards. They don't pay you very much, but they pay you like 50 cents for a 30-second survey. So occasionally I do those. But money is a good incentive to actually do surveys. So you can pay people to take surveys. That would definitely reduce non-response bias. If you get this question on a test, that's what I would say is your 2 ways you can reduce non-response bias. You continue to follow up, and you can also pay people money. All right, and this is the last kind of bias. Our 3 types of bias are sampling bias, means you don't reach the right sample. Non-response bias, you reached the right sample, but they chose not to respond. And lastly, response bias, which means you've reached the right sample of people. They chose to respond to your survey, but their responses themselves contain some kind of bias. I've got a video presentation for you. Oops. Can I say that again, what I just said?
So, Timmy,
Okay, I'm going to watch this video.
I got your blood work in, and I have a couple of questions. Okay. Just about how many hot dogs do you eat a day?
How many hot dogs?
Yeah.
Geez. I don't know. I mean, some days I could eat a couple, and some days I don't eat any.
Okay. Well, let's just say for an average, take your whole week and try to figure out what your daily amount would be.
I have no idea.
Just try.
Okay. A whole week? Average per day would be something like, I don't know, 7?
7 hot dogs
7, yeah.
a day.
Is that high?
It's a little high.
Is that bad?
Well, not good.
I mean, I'm just ballparking.
Okay, so I think you get the idea. If I don't have an anonymous survey, right? Like if I have a survey where someone's talking to you, or if you know for a fact responding to the survey is going to link your response with your email address or your name somehow, you're less likely to give an honest response. Especially if you ask something that's like remotely embarrassing or tied to your pride. There's been studies that have been done that show when a doctor asks a patient for their weight and then immediately puts them on the scale and weighs them like right after that, their guess at how much they weigh is always lower, right? People like to think of themselves as being a little bit more slim than they really are. What about what about this one? So I went to school at Texas Tech in the College of Engineering. And one thing they did as I was graduating is they asked me and everybody else what the starting salary was going to be in my new job because they were going to use this for like promotional materials. I gave them my salary as it appeared on my offer letter for the new job I was about to start. And a few of my classmates gave numbers that were just like a lot more than that, you know? And I thought I was getting paid pretty well, but the guy next to me is saying he's getting paid like 30% more. And so I started thinking, like, is that a real salary? Like, I talked to a bunch of recruiters. I've did my research online. That just doesn't sound real. And so we were talking later and kind of prying at this guy, like, you know, you said you were getting paid $130,000 to start. Like, are you serious? Is that your base salary? And he was like, well, no, it's not my base salary. It was my base salary, but plus what they said I could potentially earn up to in bonuses, and plus what they said I might get paid if I work overtime during turnarounds, and plus, you know, the value of my retirement benefits they were offering, and plus, you know, and so it was like, oh, okay, so you were kind of interpreting this in the light that would maybe most favorable to you. And I think it's because it wasn't really asked us in an anonymous setting. It was like a small group, but it was like us and the dean, and it was like he wanted to look good in front of everybody else. Maybe he was embarrassed about the salary he was actually making. So this is response bias, right? It's good to ask anonymous surveys because you want to reduce people's tendencies to inflate. It still exists, even in anonymous surveys. People still like to self-inflate their value or their worth, but happens less so if you make it anonymous. I thought this was interesting. This is a real thing. 1981, these guys asked a really, really, really long survey. It had like 100 questions. The survey had so many questions in it that by the time you reached the end of the survey, you would tend to forget the first few questions you were asked at the beginning of the survey. So you don't remember how you responded. As people are going through this survey, they were asked these two questions. Do you think the U.S. should forbid public speeches against democracy? And then also later in the survey, do you think the U.S. should allow public speeches against democracy? And even though we're talking about the same exact participants got both questions, 21% responded yes to the first question, while 48% responded no to the second question. But if you think hard about this, responding yes to the first question means the same thing as responding no to the second question. And these are the same people. So the point is, how you choose to word the questions in your survey will have an effect on how people respond to that survey. The best practice is to use both words. The best practice here is not to ask, do you oppose the legalization of marijuana, but to say, do you favor or oppose? It reduces that effect by a little bit. Like if they had asked the question, do you think the U.S. should forbid or allow? Then hopefully you would get a percentage somewhere between 21 and 48%. It's also best practice to scramble the order of words, questions, and answers in a survey. Notice what I've done here. In a good survey, half of my participants are going to get this first question that says favor or oppose, and half of my participants are going to get the second question instead. Half of my participants are going to get the question, do you oppose or favor? Because it's been shown that people are more likely to just choose the first word that pops up. It's a small bias, but it's there. Okay, so we can scramble words. We can also scramble questions. Sorry, I'm trying to circle the word question for you, but I have poor fine motor skills. Afghanistan is a issue that was generally the least popular thing that the Biden administration did, was like the pulling troops out of Afghanistan. So if you received a survey that asked you these questions in this order, asking someone a question about Afghanistan and then immediately asking an overall approval question is going to be likely to yield worse approval ratings than if you switch the order. If you ask the overall perspective first and then ask the Afghanistan question second, you'd likely get higher approval ratings. Again, because it's like, what are you thinking about when you answer an overall type question? Your brain is really thinking about specific instances. The last thing I'll say is you should also scramble the order of questions because, again, people are more likely to just choose answer choice A when you present them with multiple choice like this. So every time you give a participant a survey, scramble the order of the answer choices. So on exercise 9 on your homework, those are the 6 strategies. We've already talked about them, but that's how you would answer that kind of question. Y'all have a great day.